All right, the next problem we're talking about population. So we've got a population of alien bacteria grows and it doubles every hour. If the population begins with 100 alien specimens, and it's going to ask us two questions. How many will there be after 6 hours and how many after 18 hours? So we need to figure out our A and our B for this. Remember, A is what I start with. So I'm starting with 100 specimens. And then B is my rate. So since this tells me that it's doubling every hour, then I know that B is just going to be 2. So my function here is going to be y equals 100 times 2 to the power of x. Now that I've got that, I can go to each of these problems and just plug in what they're asking. So it doubles every hour, so I don't have to worry about converting the hours or the minutes or anything. So for 6 hours, we're just going to have y equals 100 times 2 to the power of 6. So 100 times 2 to the power of 6. And we get 6,400. And we do the same thing for the other one. So we've got y equals 100 times 2 to the power of 18. So we get 26,214,400. So those are just basic problems. Very easy. We've done ones like that. You've got a good set of examples in your notes. Number 3 is a little bit different. If we read it, it says a watch purchased for $12,000 is expected to gain value at a rate of 5% per year. So that tells me enough information where I can go ahead and write my equation. So A is what I start with. So it starts at a value of $1,200. And then to find B, it's telling me it's gaining value. So that tells me I'm going to add. And then 5%, I've got to change 5% to a decimal. Remember, if you struggle with that, you can just divide. So 5 divided by 100 gives me 0.05. So 1 plus 0.05 is just 1.05. Now that I've got those two pieces of information, I can write my equation. So y equals 1,200 times 1.05 to the power of x. Now, if we keep reading, it says, after how many years is the watch worth more than $1,800? There's a couple ways of doing this, and I've shown you in class. What it's saying is it wants to know when it's going to at least be worth $1,800. So I'm going to have 1,800 equals 1,200 times 1.05 to the power of x. Now for this, remember I told you I think it is easier to use the Casio calculator. So if I'm using the Casio calculator, I am going to put this function in exactly how I see it. So I've got 1,800 equals, remember equals is up here and it's red, so I'm going to have to hit alpha calc. That gives me my equal sign. Then I've got 1,200 times 1.05 to the power of x. X is right here. It's red, so I hit alpha parentheses, and it gives me that. Now, once I have it typed in, then I'm going to tell my calculator to solve. So notice up here it says solve. So we say shift, calculate to solve. It's going to ask me if I want it to solve for x. I'm going to hit enter. Sometimes it takes a minute, so give it just a minute to figure it out. And when I do that, I get x equals 8.31. So x equals 8.31. Now, I need to double check that. So if I plug 8.31 into my function, I need to make sure that that is worth more than 1800. So I'm going to go back to my function. 1200 times 1.05 to the power of 8.31. So notice we're almost to 1800, but we're not quite there. Since the problem says after how many years, a good rule of thumb is to just take whatever you get and round it up. So instead of this being 8.31, I'm going to round it up to 9 years. And that will be our answer for that problem. Now, another way that you can do it, and I've shown you a bunch of different ways, but another way, if you had just this calculator, the graphing calculator, I'm sorry, I'm going to put it over here. I can go into y equals, which is right here, and put in the function that I wrote. So I wrote 1200 times 1.05 to the power of x. Now, I'm trying to figure out what value of x makes this equal a number bigger than 1800. So I'm going to go to my table, so second graph, and I can just scroll down to see when this value is bigger than 1800. So when we get to 9, notice it's at 1861. At 8, it was still at 1700. So this is another way you could do it. This probably seems a little bit easier. The issue here is just that if it's a big number, you're going to be scrolling for a while to find it. But either way works. You'll have both calculators on your test, so whichever one you're more comfortable with. So if you're still writing, you got another second to jot that down. All right, so let's look at number 4. Sam takes 800 milligrams of ibuprofen for her nagging backache. Every hour the ibuprofen in her system a quarter dissolves. So they're telling me everything I need. She starts with 800 milligrams, so that's going to be my A value. Now, for B, it tells me that it's dissolving, so it's going away. So I'm going to have to subtract, and a quarter of it is going to be 0.25. 25% of it's leaving. So 1 minus 0.25 leaves me with 0.75. So that allows me to write my function, which is y equals 800 times 0.75 to the power of x. And then that next problem says when there is less than 200 milligrams of medicine left in the body, it is safe to take again. So how long will it take before Sam can take more medicine? Sorry about that. So this is kind of like that problem from before. I can set my function equal to 200, and I'm going to show you both ways again so you can decide which one's easier for you. We'll have 200 equals 800 times 0.75 to the power of x. So using the Casio calculator, I'm going to type that function in just like how I see it. So 200 equals, remember alpha, to get that red equal sign, 800 times 0.75 to the power of x. We need to tell it to solve, so we're going to hit Shift, Calc, and when it says solve for x, hit enter. And we get x equals 4.82. Remember I told you before, if you've got a decimal, you go ahead and round it up. So that is going to round up to 5. And we're talking about hours, so 5 hours. Now, if you wanted to do that on the graphing calculator, you're going to go back into your y equals, clear out what we had before, and we're going to put our function in. So 800 times 0.75 to the power of x. And then we're going to hit second graph to go to our table. And I need to see when my y value is less than 200. So if we scroll down, you'll notice at 5, it is less than 200. So we get the same answer regardless. It's whichever one is easier for you.